Satellites are the primary infrastructure. So they are the ones that are broadcasting the signal that we are finally receiving and decoding and transforming in our position. And they are orbiting in the space, and we can identify different orbits. Here you have two different pictures. Okay, in this one, this is the 2D. Okay, in the when you see the orbits from the top. Okay, and here you can identify the GPS, the GLONASS. This is from Russia. And here the different trajectories. This is a representation of the sun, and this is the Earth. Okay, you have here I'm highlighting 1, 2, 3, 4, 5, 6, and 7 different trajectories. This, for example, the sun synchronous orbit is the one that is the whole trajectory has direct contact with the sun. So there is not. So this is the best trajectory in order to guarantee that the satellite has produce enough energy with the solar panels. Okay, for example, the HEO, the highly elliptical orbit. Okay, this is this one, and is the one that is more eccentric, but also is approaching more here into the Earth. And the intermediate circular orbit or the medium Earth orbit. Okay, here is the ones is the orbit where the satellite from the GPS are located, and then we have the inclined geosynchronous orbit. Okay, is this one that are traveling or moving at the same rotational speed than the Earth, and the same with the geostationary. This is good. The geostationary are very commonly used, as you see here, by the weather services, Marsat, also for televisions, because if you are, for example, from Spain, you can locate a satellite that is all the time um, pointing out to Spain, okay, which is very useful for those kind of things. And I think I'm not missing any orbit, and this is interesting. And here for satellites, um, the so the first thing is to determine how are we determining the position of the movement of the satellite. And so the first thing is using orbital mechanics, we can finally describe the position of a satellite using the 6 Keplerian parameters, okay, which are the semi-major axis, the eccentricity, the ascending node, okay, ascending node, which is this angle over here, the argument of the of perigee, and is the position of the perigee, okay, with respect with the x, y, this plane over here. Okay. The inclination is this angular axis, okay, and the true anomaly is the position from the perigee, where is the angular position from the perigee that is we can find our satellite. Okay. So with these 6 parameters, we are able to associate or to locate the satellite. And yes, you see, we can use many different reference systems as always. And here in the picture, we already saw a couple of them. So in order to identify all of them, the one is the perifocal, is the one that is contained in the plane of the plane where the satellite is moving. Okay, and this is the P, the Q is 90 degrees, and the W is perpendicular to the PQ plane. And the Earth, as you know, this is very common, is their center inertial. Okay, this is the dx axis is towards the vernal equinox, and the on is fixed, and the earth center fix is the one that is rotating with the earth, okay, and is the one where we define the geocoordinate, the latitude and the longitude. And finally, the east north up, as you know, is the local horizontal. Okay, what you are the one that we are using on the surface of the earth. Okay, this is the north, the east, okay, and the up. Sorry, yeah. Typically, we have to transform from the perifocal to the Earth center inertial, and finally to the Earth center Earth fix. That is where we define the coordinates. Yeah, and finally, I wanted to highlight here that the satellite are into 6 orbital planes, and they are equally spaced 60 degrees in order to cover the 360.